Hi, I am Lopamudrashan. Welcome back to my channel Electronic Science Tutorial. From today we will start a new lecture series, that is the UGC Net paper solution. The first topic is electrical conductivity. Based on this topic we will solve some numericals, and these problems are from UGC Net Electronic Science question paper. So let's start our class. Okay. The first topic of electrical conductivity is current density. What is current density? The current density, which is defined by J, that is the current through per unit cross sectional area, and J is equal to I by A. I is the current and A is the cross sectional area. So what is the definition of current density, which is defined by J? That is the current through per unit cross sectional area is called the current density. If we consider one cylinder and this cylinder is totally full of electrons or holes, that means some atoms, and if we apply some voltage from the external field, then what is the current density? The current density is the, what is the current density of this cylinder? That is the current density is the current through per unit cross sectional area, and that is defined by J equal to I by A. The unit of J in SI system is ampere per meter square. Okay. Our next topic of electrical conductivity is carrier mobility. What is carrier mobility? Carrier mobility, which is defined by mu, is the average drift velocity per unit electric field. So mu equal to V by F. V is the average drift velocity and F is the electric field, and that is called carrier mobility, which is defined by mu. In SI unit, mu is expressed in meter square per volt second. Okay. So this is the carrier mobility. Our next topic is electrical conductivity. Electrical conductivity, which is defined by sigma, is the current density per unit electric field. That means sigma equal to J by F. We know we represented the current density by J and electric field is represented by F. So the ratio is J by F is the electrical conductivity. In SI unit, sigma is expressed in Siemens per meter. Due to the electrons and holes, the overall conductivity of the semiconductor is sigma equal to, we can consider sigma n plus sigma p. Sigma n is the electrical conductivity for electrons and sigma p is the electrical conductivity for holes. So sigma n is represented by n mu n. N is the electron concentration into the cylinder and mu n is the carrier mobility plus p mu p. P is the hole concentration into the cylinder and mu p is the carrier mobility. E is the electronic charge. So due to the electrons and holes, the overall conductivity of the semiconductor is E into n mu n plus p mu p. So this is the total electrical conductivity of a semiconductor. Next, what is resistivity? Resistivity, which is defined by rho, is the electrical resistance of a conductor of unit cross sectional area and unit length. Rho equal to, we can define it, RA divided by L. R is the resistance, A is the cross sectional area and L is the unit length. Okay. So resistivity is the electrical resistance of a conductor of unit cross-sectional area and unit length. The electrical conductivity, that means sigma equal to, we can define it is the 1 by resistivity. So the inverse of resistivity, we get the electrical conductivity. Okay. And the electrical resistivity, that means rho, is equal to 1 by sigma. That means the inverse of electrical conductivity, we get the electrical resistivity. Okay. Next, what is the unit of resistivity? The unit of resistivity is ohm meter in SI unit. Okay. Now, this is the problem of UGC Net 2021 Electronic Science. For semiconductor with both electrons and holes as carriers, the resistivity can be expressed as, the first option is Q into N mu N plus P mu P, Q into N mu N minus P mu P. Third option is Q divided by N mu N plus P mu P. And the fourth option is 1 divided by Q into N mu N plus P mu P. So based on this concept, electrical conductivity concept, we can easily solve this question. This question is from UGC Net 2021 Electronic Science paper. So what is the answer? For semiconductor with both electrons and holes, we can define, that is the conductivity equal to E N mu N plus P mu P, right? So what is the resistivity? Resistivity rho equal to 1 divided by sigma. So 1 divided by sigma means 1 divided by E N mu N plus P mu P. So the right answer is this. Okay. Next question. The next question is from UGC Net 2016 and from 2017 Electronic Science. What is the question? A conducting line on an IC chip is 2.8 mm long and has a rectangular cross section 1 into 4 micrometer. A current of 5 milliampere produces a voltage drop of 100 millivolt across the line. If the electron mobility is 500 centimeter square per volt second, then what is the electron concentration? And the option is these 4. Okay. So what is the answer and how we solve this problem? First of all, what is the given value? First, here we saw that is 100 millivolt across the line, a voltage drop, and 5 milliampere current produces. Okay. So from here, what we get, that is the resistance. Resistance equal to, we know, V by I, right? So from here we get the resistance value. Then if we get the R value, then what is the resistivity value? Resistivity is equal to R A by L. Okay. So R, here we calculate R. What is the value of A? The cross section is 1 into 4 micrometer. So this is the value of A. And what is the value of L? 2.8 mm long. An IC chip which is 2.8 mm long. So this is the length. 1 into 4 micrometer. This is the cross sectional area. That means this is the value of A. And here we solve the R value. So from here we get the resistivity value, right? So if we now get the resistivity value, what we will get? We will get the electrical conductivity. That means sigma equal to 1 divided by rho. So when we get electrical conductivity, then what can we do? Then we know electrical conductivity equal to N Q mu N, right? So the N is the electron concentration. This is to be found, and Q is the electronic charge. We already know the Q value, that means 1.6 into 10 to the power minus 19 coulomb, and mu N is the 500 centimeter per volt second. So this is the value of mu N. So when we know sigma value, Q value and mu N value, then what we will get? We get the electron concentration. So electron concentration N equal to sigma divided by Q mu N, right? So this is the electron concentration value. Okay. So in this way we get the solution of these numericals. So next slide we will get the solution. So what is the solution? First of all, we get the resistance value R equal to V by I. V is the 100 and I is the 5. So R is 20 ohm. Then we get the resistivity value. Rho equal to RA divided by L. R is 20. So 20 into 10 to the power minus 6. A is the cross sectional area and this value is 4 into 10 to the power minus 6, and L is the unit length of the IC chip. So this is the 2.8 into 10 to the power minus 3, and this value we get 28.57 into 10 to the power minus 9 ohm meter. Then we get the conductivity. Conductivity equal to 1 divided by resistivity, and then what is the value? That means 1 divided by 28.57 into 10 to the power minus 9, that is equal to 3.5 into 10 to the power 7 Siemens per meter, and therefore the electron concentration is N equal to sigma divided by Q into mu N. Sigma is value 3.5 into 10 to the power 7 and Q is the value is 1.6 into 10 to the power minus 19, and mu N is given, that is 500 into 10 to the power minus 4, and we get 4.38 into 10 to the power 27 per meter cube. Then what is the centimeter value? 4.38 into 10 to the power 21 centimeter cube. So this is the solution of this problem. Okay. I hope you understand this topic. Thank you. If you like my video, then please like, share and subscribe my channel. Thank you.